Welcome to Spring LIB.
So we're going to start by having this system that has two masses. We'll call the first one M2, and then the second one here, I'll put in red, is M2, right? And they're attached to a spring. It has a spring constant of 100 newtons per meter, and it's given an original amplitude of 0.2 meters. And we compress this and then let it go. And it talks about the time when it returns to its equilibrium position, that the second guy is just starting to leave, right? It wants to know that speed. But that speed's just the maximum speed that it would obtain passing through the equilibrium, which we know is equal to A omega, right? A is 0.2. Omega is the square root of K over M, but it's both M's, right? So that is 100 over 9 plus 7, which is 16. They chose numbers that were perfect squares, which makes this come out slightly nice. Okay. And so you're going to get 0.5 meters per second. Okay. So that's the maximum speed. The second thing it wants to know is after they split up here, right? And this has stretched its full amount. So it's moved whatever A is. The second guy is somewhere over here, and it wants to know that distance D. So we need to calculate where they both are. So I'm going to make a little bit of room here. So first I'm going to calculate where the M1 is, right? We know that it's a distance A away, a new A, right? So I should indicate this is like A prime. And we're going to find that by saying this speed, this 1/2 m1v squared, all that energy is going to get converted into potential energy at that point, right? So I can solve for my new A by rearranging here. You notice the halves cancel. So you're going to get V times the square root of M1 over K, right? So you get 0.5 times the square root of 9 over 100. So you get 0.15 meters, okay? And we need to know when that takes place. Now, to go from the equilibrium position here to full stretch is 1/4 of a period, right? So I'm going to take that 2 pi, divide by 4 in my period formula. And again, I'm talking about M1 and K. So if you do this, I find that it's about 0.47 seconds. Okay. Now the other guy's just moving at constant velocity, right? So he's just x equals vt, and his velocity is 0.5. And after 0.47 seconds, you find that he's about 0.24 meters. And therefore, those guys are 0.09 meters apart.